over. By the table of values, you can see repeated x's. You know it's not a function. By the vertical line test, you can see it's not a function. Okay? Not a function. So I'm going to add to this definition up here, how can you tell, is if y is so-called locked up by a square. Okay. So if it's locked up, y is locked up in a square. Now we can solve that, I'll show you, but what it does when you solve this, it actually creates two x's. Okay. And we know by the table of values and visually, when y is locked up by a square, that means if you plug in a y and then the opposite y, I could plug in 5 and negative 5, and both will give me positive 25. A square takes a positive or negative number and spits out a positive. You square something, you always get the positive. Okay, because a negative times a negative is positive. Okay? So a positive number squared is positive, a negative number squared is positive. Okay? So you square 6 and negative 6, both of them are going to spit out positive 36. And that would be, and that is your x value that's being spit out, it will be repeated. Okay? Because 36 results from both negative 6 and 36 results from positive 6, and so forth. Okay? So locked up by a square means two values of y are going to create the same x, repeated x's. Now I'm not quite done here. Is there another situation where when you plug in something, it could be the positive or negative version, but it's still going to spit out a positive? Something besides squaring that will always spit out a positive. Let's say I plug in either 5 or negative 5 to this other thing, it's always going to be, the answer is going to be 5, or some other positive number. It's what? Square, you square opposites, and you get a positive answer. What else can you do to something to opposites and still get a positive answer? Absolute value, right. If I have the absolute value of 5, it equals 5. If I have the absolute value of negative 5, it equals 5. Okay? So absolute value bars have the same effect as squaring. So I'm going to add that. So if y is locked up by a square or by AV bars, okay, then it's not a function. Okay. Now your x can be squared, obviously, absolutely. Okay, you're solved for y, there's a clue, solve for y, if your x is squared, that's great. Solving for y makes your function. And here, I'll come back and when I sort of scan in the completed thing, I'll include the visual for this, but this is y, solve for y, no problem. Okay, if I graphed y equals square root of x, what kind of shape does it make? The V, right. Now, what do you think is going to happen if I do x equals absolute value of y? Exactly, yeah, it's going to tip it over. Okay? Because I could plug in opposite y's and they're going to spit out the same x, repeated x's. Same as with the parabola situation. Okay. Real quick here, I'm going to show you algebraically how it happens. If I take x equals y squared, I'm going to turn it around as y squared equals x. This is something we're going to see in a later unit working with radicals and exponents, what's called the square root property. If I want to solve for y, I can. I can solve for y. That doesn't mean it's a function, though, if I have to get rid of a square or absolute value bars. Because I would square root both sides, but when I square root my x, I'm required to put a plus or a minus, because there's two things of values of x that will make this true. Okay? So squaring a square root solves for y, but I end up with two answers. I end up with a negative square root of x and a positive square root of x. Okay? So I'm going to have repeated x's here, and that's the problem. And the same thing, remember how we do it when we solve an absolute value equation? We drop the bars, and y will equal negative x, and y will equal positive x. X to the left, x to the right. Same effect. Okay, okay with that? All right. So let's get into function notation, meaning how we write functions now. Okay? We understand what a function looks like, how to recognize if it is a function, but now we're going to look at the formal notation. And then how we use it to evaluate functions when we're just looking at that. So I left some empty space for notes here. We'll bleed through there, sorry. Okay. So notation just means how we write something. So we're going to be writing these in a formal way. Now some common ways, some common letters that are used to name functions. If you know you're talking about a function, you don't have to use, let me put that, you don't have to use function notation if it's a function. There are plenty of functions you can write in other ways. There's still a function, even if you're not written in function notation. But if you put it in function notation, you make it more formal and easier to deal with. Some common letters used for function notation, F is the most common. But if you're working with multiple functions, or if you're working in like a real-world problem, some people like to use the letter that goes with the word problem. So common things for functions, but not, are like F, G, H, or K. Other things might be used depending on the context, but that's pretty common, are used to name functions. Okay. So, what this means, what we're saying is, y is a function of x. Y is a function of x. That means if we plug in an x into a function, we get a value. It spits out a y. Okay? Y is a function of x. Put in an x, and y depended on what x was. And then that generates an ordered pair. Okay? So a function generates that ordered pairs. Y is a function of x. Now this is written mathematically as y is a function of x. Now parentheses are used in a lot of ways in math, depends on the context. This does not mean f times x. Okay? This is a function of x. So what we say is f of x. Okay? That's how we say it. It's not f times x. It's f of x, or function of x. Okay? Now what this means is that y depends, like I said, y depends on x. Now y is the value of the function. What is the function worth? Well, I don't know. It depends on x. What's the function worth? I don't know. It depends on it. Well, if x is 1, okay, we can plug in that and then we'll find out the value of the function. Okay? Y is the function, or the value of the function, but what that value is depends on what your x is. Plug in one x, you get one value. Plug in a different x, it has a different value. You put all those values together as ordered pairs, and you have drawn the function. And so this also then leads us to our two different variables. Okay? So y is what's known as the dependent variable, because it depends on x. X is known as the independent variable, which means you can choose any x, and when you choose that, y is going to depend on what you chose. Now you have some restrictions. If you have infinite domain, unrestricted domain, you can choose any x. Okay? But some are restricted, depending on the function. And that's a topic you explore more deeply in college algebra. Okay? When you have restricted domains and what's included and what's not. Okay, so writing things in function notation, let's say, for example, 4x minus y equals -3. Is that a function? Well, what family does it belong to? What picture is it going to make? It's a line, right. Clean x, clean y, it's linear. It's part of the linear family. And all linear equations are functions, right? Except for, is this a vertical line? You got an x and a y, what kind of line is it? Diagonal, horizontal, or vertical? Diagonal. Both an x and a y is always going to be diagonal. Just a y, horizontal, just an x, vertical. And that's all covered in that graphing handout too, so if you're a little shaky on that, definitely read over that. Okay? So if it has an x or a y and they're clean, or an x and a y, it's a line. If it has both an x and a y, though, it's specifically a diagonal line. So this is a function. Diagonal lines are functions. But it's not written in function notation. Now here's what you cannot do. Okay? I can't just take 4x minus f of x equals negative 3. Okay? Yes, y equals f of x. But until I'm solved for y, I can't just substitute f of x in there. Okay? So don't do that. Okay? What you need to do if you want to write something in function notation is you need to solve for y first. Okay? So use your addition property, use your properties of equality to solve for y. I'm going to minus 4x on both sides. There's a negative y equals negative 4x minus 3. Now, of course, I want a positive y. So I multiply or divide everything by negative 1. Basically, if I want to flip a sign, just make sure I flip every other sign. So this equals. And now this is in slope-intercept form, which, as I pointed out earlier on that handout, that's the same thing as function notation. I just need to change y for f of x, because y equals f of x. That means they're interchangeable. Once you solve for y, you can just write f of x instead. So this becomes, in function notation, f of x is equal to 4x plus 3. This is just a more algebraic way of writing. I know a line is a function, but now it's more formally written, and I can, when I evaluate it, it's going to be in a more formal and clear, effective way of showing what I'm evaluating and showing my independent and dependent variable and the value of a function and what it means. Okay. So, if I take that function, I'll use this one specifically, and I want to evaluate it. Okay. So let's say I wanted to evaluate the function. I'll take f of x is my general function. This is a line. If I plug in an x, I get a y, and so forth, and so on into infinity, and I can draw that line. That's the general function when I say f of x. But if I want to know, out of all those infinite points, a specific point on that line, that means I want to know the value of the function at a particular x. Let's say, for example, I want to find f of 1. What this means is, what is the value of the function? What is the value of the function? And when I say the value of the function, what I'm saying is my y. Okay? I want to know my y is. What is the value of the function, which is y, if x equals 1? So f of 1 is like f of x in the general function. F of 1 is saying out of all those infinite points, when x is 1, what is y? So, f of 1 means this function, in function notation, I can say this function is defined by this expression. And different functions are defined by different types of expressions. This function is defined by a linear expression. Hence, it's a linear function. I know to make a line. Other functions are defined by quadratic expressions or radical expressions or rational expressions, absolute value expressions. Okay. This line, evaluated that expression, f of 1, a point on that line is 4 times 1 plus 3. Now, what I know right here is that what I was doing here is that right there I'm saying that's my x value. Okay. And what it spits out, x is 1, f of 1 is 7, right? Okay. So let me just shorten that up then. I have f of 1 is equal to 7. Okay. This right here is my y. So y equals 7. Okay. And I found that 7 by plugging in my x of 1. Which means once I find the value of the function at 1 is 7, I can also write that as an ordered pair. Because there's infinite ordered pairs on this line, what does this particular ordered pair look like? Yeah. My x was 1. That's my independent variable. So when x is 1, the value of the function, or my y, is 7. And that is one of the infinite ordered pairs on that function. I can evaluate other x's. There's infinite x's I can evaluate. That make sense? Okay. All right. So if something is a function, you can write it in function notation. If it's not a function, you can't use f of x. Okay? You may be able to solve it for y, but you can't. But you're going to get two answers because that means you have repeated x's. So normally you don't even solve it for y. Okay? But just because it's a function doesn't mean it has to be solved for y. But if you want to put it in function notation, it does. So we're not going to do all these right now. This is other stuff I need to touch on, but this is definitely something you can practice, and I'll fill out, and you can check your work. Here we've got 5 different relations. Okay? They may or may not all be functions, okay? But I do say they're all linear equations. Okay? So you can see that by looking at them. They're all linear. They have clean x's and y's. Okay? So if they're linear, they're probably functions, unless they are functions, unless they are a vertical line. Yes. So if you see any vertical lines here, you know it's not a function, and you cannot write it in function notation. Now, any type of family, linear or not, can be written in function notation. These first two, standard and slope-intercept form, are specifically for linear, but then also function notation. So what I'm asking you to do here, for example, like this first one, this is a linear equation, horizontal, vertical, or diagonal. Diagonal, x and y. Now, which form? It's already in one of these forms. Which is it? Standard. Right. So I would go ahead, since A is standard form, I'll go ahead and write it there. There's nothing to change there. Okay. For the other ones, decide what they are and put them in the correct line. Okay. If they're standard form, put them in A. If they're slope-intercept, put them in B. And if they're already in function notation, put it in C. But then change to the other forms. Okay. Now we know from this example up here, it's a linear diagonal line. You know it's a function, so you can solve it for y. And that will be slope-intercept form. And then once it's solved for y, all you do is write f of x instead of y, and you have function notation. That make sense? Huh? So each of these is going to be in one of these forms already. Put it in the correct line. Change it to the other two forms. Okay. I'll move on to some other things now. That should, we can touch on this on Tuesday, and I'll also post the full solutions to that. It's just about equation manipulation, using your properties of equality to move things around and understanding what each of the forms looks like. Okay? So if you need more practice on it, that's right there. If you're not comfortable with that, definitely practice that, and we can touch on Tuesday. You'll see the solutions posted. Any big questions on that though, or confusion what I'm asking for the directions? Okay. So evaluating, just like this example up here, specific evaluations. And this is more about sort of making some tips and tricks to not make careless mistakes, understanding what the function's asking for, how to use your calculator as well to assist you in this. Here I've listed 4 possible functions. I use different letters to name them because I want to distinguish between them. We got f of x is a linear function. Now, is this horizontal, vertical, or diagonal? Okay. But doesn't a diagonal require an x and a y?
Already like in y form. So.
Yeah. Right. You're not seeing a y, but it's actually there. It is solved for y. We could rewrite it as y equals 6x minus 2. When you're graphing, sometimes you prefer to just rewrite it with a y because then it's easier to think of for graphing purposes. Huh? It means the same thing. So yes, it's a line and it's a diagonal. Because it was solved for y, we could write it in function notation. Same thing. Huh? Quadratic function, g of x is a quadratic. I'm going to skip back here. K of x is an absolute value function. That'll make a v. Okay. Now, I don't have to worry about whether it's an upward v or a sideways v. I know it's an upward v because it's a function. If it's in function notation, it's a function. Okay. And this is y equals, if I wanted to rewrite it, y equals absolute value of x minus 2. Okay. Or y equals negative x squared, so forth. What about this one right here, though? What about the h of x?
It's the same thing.
Same thing as what? What kind of function is it? What family? It's a linear, and what'd you say? Okay, specifically horizontal. Remember, this is just a constant right here. Okay, you've got no variable here, but you do have a variable here. You can rewrite your function notation as a y. And remember, if you have a clean x or a clean y or both, you have linear. Does that make sense? I didn't hear the answers over here, so I want to make sure is that Does that answer the question? Okay. So if it's just a y, it is a
It's just
vertical line.
horizontal. Remember, vertical lines aren't functions. You can't write a vertical line in function notation because you can't solve for y. If a vertical line is x equals something, how do you solve for y? That's why it's not, another reason why it's not a function. So if you've got a line that's not diagonal, you know, and it's written in function notation, it has to be y equals, it has to be horizontal. Okay. So there's some other ways of looking at it there, and of course I could write that with a y too. So that's one thing. And so when evaluating, you want to be really careful whether you do this manually or in your calculator. So let's do f of -3. Okay. And if you can either enter in the calculator directly in parentheses, or you can store the number and then and have the calculator and then just enter the function with x's. Okay. So depending, you know, what's more efficient, it depends. This is a very simple linear. So f of -3 means f of -3 is this linear expression with -3 plugged in for x, always in parentheses. Now I can evaluate that mentally by hand, or I can enter it in my calculator. I can see that's -18 minus 2 is -20, but I just show as a calculator thing, I could store that -3, but it's maybe a little overkill for something this short. I can just do 6, and I always write it down first though, so I don't forget my parentheses, and I type it in exactly like I see it. 6, parenthesis, -3, close the parenthesis, minus 2. Okay? That tells the calculator exactly the order of operations and where the negative is, and it evaluates to -20. Okay. Now, the value of this function, this linear function, when x is -3, is -20. The value of the function is -20 means y is -20 when x is -3. So how would I write this as an ordered pair? And that's one of the infinite points on that particular line. Now, calculators are especially useful too when you're using, for example, fractions. Always enter them in parentheses. Okay? Either store 8/9 and then just enter, you know, this, or do 6 parenthesis 8/9 close parenthesis minus 2. Okay? Let's look at g of 0. This is a nice case if you think logically about this. So we've got g of 0 is equal to, now that negative is part of the function. Another reason parentheses are important. That negative is not the x. You were replacing x and only x with the value of x. This function has a negative, and then the x gets replaced by 0. Minus 4 times 0 plus 1. You do not need a calculator for this one. It's just 1, yeah. Anytime you have 0, and when x is 0, any term with a variable, poof, it's gone. Yeah. All variable terms will disappear. So whenever you're evaluating x equals 0, the answer is the constant. Okay. So this is equal to 1. And so then the order pair, 0, 1. But again, as a cautionary tale though, here we've got the g of -5, for example. We're putting in a negative number. This is a more complex function. That negative is part of the function. That negative stays there, and then the -5 is in parentheses. Okay? This is why I'm such a, you know, a nag about these parentheses. It can throw you off with exponents because that includes the base. -5 squared is positive 25, but then this outside negative that's part of the function makes it -25. Okay? This -4 x, which -4 times, yeah, and it makes it a positive 20 there, yeah, and then plus 1. Okay. This one, as more complex it gets, may help to use that store button. Okay. So I would take -5, not visible there, store right above the on key, where, just use your general x, okay. Enter. And now I can just cleanly type that uglier looking function exactly like I see it, and the calculator will do the substitution with and understand the parentheses. So I don't have to use parentheses if I do it that way. I have to put in the negative, which is don't use subtraction. Negative's below the 3. Negative x, and then push the square button. Okay. Minus 4x plus 1. Okay. Exactly like I see it, and it will know to put that in parentheses if you've stored it. Giving me the -4. written as -5, -4. What about h of 4? Okay, find our h function. And this is saying x is 4.
It'd just be 4.
Okay.
That would be it, wouldn't it? It'd just be 4 and then what's that?
Well, look at the function. When h of x, h of 4, means that we plug in 4 anywhere we see an x. Okay? So I'm going to write, I have to write what's already there. The only thing I'm doing is I'm substituting 4 in everywhere I see an x. Is there an x?
No.
Yeah. So there's nowhere to plug in the 4. Think of a horizontal line. It doesn't matter what x is. Y is 7. Yeah. It's a good one to start visualizing. Yeah, that's tricky at first when you think it's like, if you just write it down just like you are the others, and you say, okay, whatever that is, that x, I'm substituting wherever I see an x. Well, I write down the expression, just a constant, nowhere to plug in a 4. And I think, oh, okay, if x is 4, it doesn't matter what x is. The whole point of this horizontal line is that y is, it's defined by y is 7 regardless. That's always the answer. Any x will give you a y of 7.
So then, yeah, it'd be...
Does that click? Is that, yeah. So, and that's, if you listed all the points on a horizontal line, your x's are infinite possibilities, but y,
It's not showing up.
oh, sorry, there we go. X has infinite possibilities, you plug in any x, but regardless, that horizontal line is always going to be going straight across through 7 on the y-axis. Okay? That's going to have an infinite domain, but just, boom, a range of 7. It's always that. Y will always be 7. And then, yeah, the rest of these, I'll fill in if you want to get more practice. There's practice of this on the homework, and then I'll fill these in if you wanted to do this extra practice and check yourself. Any big questions, though, or confusions on sort of method? Be very organized, use parentheses. Calculator's a good assist, but you have to make sure you're setting it up correctly and understand what it means to begin with. Okay. Otherwise, the calculator is a tool that you can't control, because if you don't understand the meaning behind it, you can get lost in it.
What about the whole fractions?
With the fractions, always enter fractions in parentheses, no matter what you're doing, this or not, because fraction is a division problem, and if you don't enter it in parentheses, sometimes that will mess up the order of operations on the calculator. So as a rule, you want to tell the calculator this is a unit. Okay, it's not just an operation. So this is just going in the linear one. I can either enter it as 8 divided by 9, and then store it in x. It's going to convert it to a decimal, but it knows what it's doing. And then just enter 6x minus 2. Now, I don't want decimal answers, though. I'm glad this came up, actually. I don't want a decimal answer. Because that's repeating, and I'm not dealing with that. I need exact answers. So if you haven't done this before, this is a very useful button. The math button, if you get a decimal answer, I want you to give answers in fractions. In general, lowest terms fractions, push math. And then enter, because once I push math, I want that, see how it says fraction? If I push enter, it's saying, okay, you want me to turn your answer into a fraction? Push enter again, say, yes, I do. So it's math, enter, enter. We'll turn a decimal into a lowest term fraction. So whether I store it or whether I just enter 6, parenthesis, 8 divided by 9, 6x minus 2, either way, I'll get the same